This is a math story that I call The True History of Riemann Sums with Socrates and Amphibianes. You will play the part of Socrates, and Amphibianes will play the part of
myself.
Through painstaking research, I have traced the beginnings of Riemann sums to ancient Greece. I have discovered a lost manuscript about the greatest philosopher of all time. Though long since forgotten, at one time he was so great that people called him Socrates. This manuscript describes a dialogue between Socrates and one of his students, Amphibianes, who was always hopping all over him with questions. Throughout the following reconstructed dialogue, notice how Socrates employs the Socratic method, by which the student is brought to knowledge through queries such as, "What's so great about that?" Since this is a dialogue in two parts, you will play the part of Socrates, and Amphibianes will play the part of himself. Make sure to join in at the appropriate time.
Oh, great, Socrates. I want to learn the secrets of Riemann strums.
Perhaps you mean Riemann sums, Lilyhopper.
Are you calling me a liar? I want to learn how to play so that I can get a lot of loot like all the other musicians in Greece. What good are Riemann sums?
Riemann sums, Lilyhopper, help you to compute areas under curves by using rectangles.
Curves using rectangles? Sounds tricky. Why don't you tell me more, if it's okay by you?
Imagine a curve that you can find the area underneath over a certain interval.
Like x squared plus 2x between 1 and 5, for example?
Yes. Now divide the region into units of equal width.
How about 1 for starters?
Good. Then you would construct 4 rectangles. Each of those widths would be 1 unit.
Okay, how do you calculate the height of the rectangles?
Rectangles are 4-sided polygons.
Why not call them fourgons? How do you calculate the heights?
Do you want to use right rectangles?
Of course, I want the right fourgons. Why would I want the wrong ones?
Then you compute the height by using the right-hand endpoints of each interval. So the area is 1 times the quantity 2 squared plus 2 times 2, plus 1 times the quantity 3 squared plus 2 times 3, plus 1 times the quantity 4 squared plus 2 times 4, plus 1 times the quantity 5 squared plus 2 times 5. I hope you kept up with that.
A foregone conclusion, I'd say, but it's incorrect.
Yes, but you can make the rectangles narrower.
Even if you use twice as many, you'd still have an incorrect foregone conclusion. Also, I'd hate to write all those terms out. I'd get a leg cramp.
Use sigma notation.
Sigma is Greek to me.
It's Greek to everyone. You could write it as 1/2 times the summation as k goes from 1 to 8 of the quantity 1 plus 1/2 k squared plus 2 times the quantity 1/2 k.
But it's still an incorrect foregone conclusion, even if you used more of them, like 10. 4/10 times the sum as k goes from 1 to 10 of the quantity 1 plus 4/10 k squared plus 2 times the quantity 1 plus 4/10 k.
Suppose you take the number 10 and replace it, let's say, by the letter n. 4 over n times the summation as k goes from 1 to n of the quantity 1 plus 4 over n k squared plus 2 times the quantity 1 plus 4 over n times k.
That's some Riemann.
No, it's a Riemann sum. Now, if you let it go n go to infinity, you will have the actual area under the curve. The limit as n goes to infinity of 4 over n times the summation as k goes from 1 to n of the quantity 1 plus 4 over n times k squared plus 2 times the quantity 1 plus 4 over n times k equals 196 thirds.
Wow! When you go to add them all up, you'll fill in the whole space. There's nothing left.
Left-hand sums, frog face, are exactly the same, only different. You simply use the left hand of the interval to calculate the height of each rectangle. The limit as n goes to infinity. You guys got to be going along with me on this one, okay? 4 over n times the summation as k goes from 0 to n minus 1 times the quantity 1 plus 4 over n times k squared plus 2 times the quantity 1 plus 4 over n times k is equal to 196 thirds.
Shifty! It seems to fly in the face of logic that they would be the same. Now, what if I picked a different interval, let's say from a to b, or even a different function, say f of x?
Simple. The left-hand sums would be the limit as n goes to infinity of b minus a over n times the summation as k goes from 0 to n minus 1 of the function, quantity a plus numerator b minus a over n times k. And the right-hand sums are the same, only different.
Slick! At the risk of being a tad political, I'd say it's the mother of all area functions.
That's no bullfrog, but what's so great about that?
Don't you see? There is no limit to the possibilities, and I owe it all to you for helping me to integrate these ideas into my life. I can hardly wait to get back to my pad to do some more.
So that is the true history of Riemann sums, TMC.